Welcome to solverfy.
This is the answer to Chapter 15, problem number 79 from the Smith Organic Chemistry textbook. And this problem asks us to look at the radical chlorination of ethane. And we're told that it forms two minor products, X and Y. We're told that their molecular formula is C2H4Cl2. We're given a little bit of NMR data about each one. And asked to derive the structures. And then lastly, we're asked to draw a stepwise mechanism, pardon me, that shows how each product is formed. Okay, and so to begin, whenever we're given a formula and asked to come up with a structure, I think that the best way to start is to calculate a hydrogen deficiency index, or the degrees of unsaturation. And so for this one, it's going to be 2 times 2 plus 2 minus 4 minus 2. So that's 2 times the number of carbons plus 2 minus the number of hydrogens minus the number of halogens. And so in this case, we end up with 0. And so there's no unsaturation here, which makes sense. It's only a 2-carbon molecule, so we can't really have a ring. And it's unlikely that we would have a double bond. Okay, so we're not given integrations for these NMR signals. We're just given chemical shift and splitting pattern. And so right away, what I noticed for X is that there's only a single signal. And so the fact that there's only a single signal means that the hydrogens in this molecule have to be equivalent. And the only way that that can really be true is if this molecule has an axis of symmetry right through the middle. And so it's going to look like this. 1 chlorine on each of the carbons. And that's why we only get a single signal, a singlet, because all of the hydrogens in this molecule are equivalent. So then looking at Y, there's really only one other possibility that we can make. Since this formula is so small, it's only 2 carbons. And so to get 2 signals, the hydrogens on each of the carbons are going to have to be non-equivalent. And the only way that we can really draw that is like this. And so in this case, our doublet at 2.1 ppms, I'll call that signal 1. So that's going to be these hydrogens. And then our other signal, signal 2, is going to be this single hydrogen split into a quartet by its 3 neighboring protons. Okay, so there's our structures for X and Y. So we're also asked to draw a mechanism that accounts for the formation of these 2 products. So to start, we will have our chlorine, so our chlorine gas, Cl2. When that is treated with, let's say, heat, so when it's heated, this breaks into 2 chlorine radicals. So there we go. And actually, let me move this over. Okay, because I do want to make sure to indicate that this is the initiation step of our reaction. So I for initiation. Okay, so that's the initiation step. So we now have an active radical species in this reaction. So next we're going to have our propagation steps. And the propagation steps here are going to look like this. So We have one of our chlorine radicals that we formed in the initiation step, and it is going to come along and grab a hydrogen. So that's going to look like this. The electrons of this bond cleave homolytically. So after this first propagation step, we have this. Yeah, I'm actually, I'll just erase this because I do want to fit the second part of this step on this line. So just understand that HCl is also produced here, but we'll just look at the active species. So we now have a radical on one of our carbons here. And so that's actually going to react with another equivalent of chlorine gas. So Cl2. It's always a good practice to draw your electrons in. And so this is going to look like this. So the Cl-Cl bond cleaves homolytically. And this is going to regenerate a chlorine radical. Okay, and so that's like our common propagation step. So that step is common to both X and Y. However, here is where they diverge a little bit. So if we are going to draw the formation of Y first, so Y is going to look like this. So we have this molecule that we just made. That looks like this. And we have our chlorine radical that we just generated or regenerated. And so they're going to react. So we now have a radical on this carbon, which has already been chlorinated once. And just like in the second part of the propagation step above, that can now react with another equivalent of chlorine gas. So, like that. And that's going to get us to our product Y. Okay, and again, that does regenerate the chlorine radical to keep this reaction going. So this is part of the propagation step. I'm just distinguishing the propagation steps that make Y from the propagation steps that make X. So X is going to be largely similar. The only difference is that for X, we're going to take a hydrogen from the other carbon. And so that's exactly what I'm drawing here. Pretty much identical to the steps that make Y, just happening at the other carbon. So the carbon-hydrogen bond cleaves. The carbon now has the unpaired electron on it. and that will react with another equivalent of chlorine gas. So again, the radical's here now. This will react just as we've seen before, immediately above it. And so that is going to give us our product X, as well as regenerating the chlorine radical. Oops. I said one thing and I drew something else. All right, so CH2Cl, CH2Cl. So there's our product X. And then again, as I said, this will also regenerate the chlorine radical. So the termination step, I'm going to put up to the top right here, just to save having to start a new page for this very short step. So the termination step, remember, can be any two radicals coming together and quenching one another, so that after this step, there is no more reactive radical species. And so I'm just going to use two of these chlorines. So two chlorine radicals can come together. And when they do, we get Cl2 back. And there's now no active radical to continue propagating this reaction. So that's going to be our termination step. And this is the stepwise mechanism that shows how X and Y are formed. And then again, the structures of X and Y are here. But just to review this first page, this is how we derived them from NMR data. And that's the answer to chapter 15, problem number 79.